Hi everyone. In this lecture, I will add a client-side load balancer, and I will manually set the service to use in the load balancing. In the coming sections, we will replace this with discovery service and API gateway instead of manually adding the services to the load balancer. Now I need a new dependency first, Spring Cloud Load Balancer. So let's add this dependency to the main PAM.xml file with the already defined cloud version in the Elastic Query web client. As you can see, I already added a load balanced annotation to the web client builder. To use this load balanced annotation, I need to use it on the web client builder instead of web client directly. Then I need to add a new class to configure service instances. Let's call it as Elastic Query Service Instance List Supplier Config. So I will create this class under config package and implement Service Instance List Supplier interface. I will override getServiceID and get methods. This should be a configuration class, so I will add configuration annotation. I will also mark this class with primary annotation, as I want to use this class instead of the other implementations that comes with Spring. Primary annotation gives implementation priority to be loaded by Spring. Then I will inject Elastic Query Web Client config to be able to use inner configuration object web client here. At this point, I need to update the config to add the instances and then use this config in the overwritten method. Let's go to the config file for web client and create service ID property with Elastic Query Service value, and also the instances property under the web client with ID, host and the port, using Elastic Query Service 1 localhost 8183 and service 2 with localhost 8185. This will be a list of service configuration and includes ID, host and port for service instances, as you see. Let's also update configuration data class and add another nested class instance with ID, host and port properties. And then I will create a list of instances property in the web client class. Alright, I will now return to service instance list supplier and override the getServiceID method to return the service ID that we set in the configuration. And then I will override the get methods that will return a simple Flux object with the just method, which includes the instances that we defined in the configuration. Remember that Flux is a reactive stream that can emit 0 to n elements. Now I can update the web client configuration and add load balancer client annotation with name Elastic Query Service, which is the service ID that I set in the configuration. And then I will set the configuration class Elastic Query Service Instance List Supplier Config, which is the class that we have implemented. And finally, I can now change the base URL in the web client configuration to use the Elastic Query Service as the host name, which will in turn forward the request to one of the services behind. this Elastic Query Service is the service ID that I set on the configuration and return from the getServiceID method in the Service Instance List Supplier implementation class. Please remember to commit and push your config server changes again here. Now I can run this web client to check if the load balancing that we have implemented is working. For that, I will add another query service definition to the services compose file and run the service instances on different ports. One is on 8183 and the other one is on 8185. Remember that we have defined these ports for the instances on the Elastic Query Web Client configuration. Let's change logging in the getDocumentByText method of query service and use port in the logging. I will use value annotation to obtain the server port definition and then use this port in the logging to be able to see which port is the service running. Then I will run maven install command to create the Docker image from start. For maven install, either run config server before running maven command or use skip test option as query service requires config server for a successful context load. Before running Docker Compose up command, let's set the logging to info for query service to be able to see the logs that we wrote for the port inspection. And also double check that you push the config server repository changes. Then I can safely run Docker Compose up command. It will take a while to start all microservices as they are doing some updates before running to be able to do some initial checks. If you have trouble running all components together because of insufficient RAM or CPU, you can simply omit Kafka cluster in the environment file and also comment out Twitter to Kafka and Kafka to Elastic services in the services YAML file, and then run the compose up command again, because running Elastic cluster and query service is enough to be able to test the web client. Now I can follow the logs for both instances of the query service using docker logs commands in different terminals. Then I will start web client and open browser and try to run a search on the Elastic Query Service. As you see, load balancer forwards the request to instances one by one using round-robin algorithm, which is the default load balancer behavior. Alright, great job so far. You have implemented a client-side load balancer. Remember, we will replace this load balancer with discovery service and gateway, and then we will not need to set the instances of the query service manually. Now in the next lecture, I will create a Docker image from the web client and run everything in the Docker. So I will see you in the next lecture.